Okay. Good morning, everybody. Good morning. Sounds very tired. I hope you wake up a bit more during the talk. But I'll try to keep this very interactive, and you'll get to do something as well, so you cannot just sit in and watch and sleep. But we'll want to do some monitoring and kind of do as much live as possible. So how did I get started with this talk? So when I saw this tweet, that was kind of the starting point how I thought about this entire talk. That's kind of like as soon as you have a distributed system, stuff can get a bit more interesting, especially for the monitoring side, unless of course you like this kind of murder mystery where you are trying to search for little clues here and there, and you enjoy logging into servers to find some entry here and something else there. But probably you don't, and you don't have to do that. And this is probably what a lot of you, or a lot of us, have in their applications. And for a long time, you're just sitting there and think, well, this is fine. And then there are normally two cases. Either you're not monitoring well enough, or everything is really fine, though I don't really believe it. Until at some point you figure out that not everything is fine anymore. And we don't really want to get to that point where everything looks like this, and pretty much the world is burning and everything is crap. So we will try to avoid that and find out better solutions before that. Final tweet, don't worry. Sam Newman, he's also very big in the microservice ecosystem. He says like the first two things you will need is, the first one is you need to have that kind of centralized logging and aggregation of data. Otherwise you will just log into various servers to find bits and pieces of information. And you probably also want correlation IDs so that you can actually correlate like calls at one end of your system to calls to the rest of your system. We'll get to that at the very end. Okay, so kind of the bottom line is we want to monitor and log and ping and trace all the things, and we'll do all of that live. So just what are we using for 2 minutes, and then we'll jump into the demo. So why am I even talking about that? I work for Elastic, the company behind Elasticsearch, Logstash, Cubana, Beats. We had previously it was called the ELK stack, Elasticsearch, Logstash, Cubana. We are trying to get rid of that name now because there are Beats now, and this talk will make heavy use of those Beats, and there is no B in ELK. And we were already thinking about how to rename that entire thing, and we came up with Belk or ELK B. And it even had like a bee body and elk horns, the logo. But since we're always about scalability, we kind of figured out that that wouldn't scale. Like even marketing is kind of about scalability, because what if we add more products later on? So we are trying to rename the entire thing now to Elasticstack, where is also the company in there. And that's what we'll be using. I'm part of our infrastructure team. So we do stuff like Jenkins tests, Docker images, everything around AWS, internal tooling. You want to run a service, we can run it for you on Kubernetes now and stuff like that. And I always say this is a Unix pipe. I kind of piped it out into developer advocacy. So I speak a lot about all the nice stuff that we do and provide out there. So this is a Hello World application, and it is very highly monitored, but I'm trying to keep it as real as possible. So we're using proper certificates, and it's kind of doing the right thing. And so it's not just like totally abstract from what you would do, but properly automated and everything. So how does everybody log and monitor? Who is still using SSH and tail? Anybody? A few, okay. Well, you have kind of come to the right talk. Because I think at least if you have more than a few servers or services, that's not going to scale very well for you and be fun in the long run. So we can find something else. And then there are lots of other solutions, and one of them is using our stack, and well, I will demo our stack. If you want to see the code, I will have the link at the very end, so you can just check out everything and take a picture at the end if you think it's interesting. But all the code is up there, so you can just see it and kind of use it as a cookbook or template for whatever you want to use with our example. That is probably the most relevant link, and I will tweet out the slides afterwards, so you can get all the slides. Of course, you can take pictures as well, but you don't have to. So I'll take a very simple application. I'm using Spring Boot, though I'm not using any fancy Spring Boot services. It was just, I need something that probably throws around JSON or can do remote calls. So it's kind of RESTful or whatever. I'm not even going in too much into the REST topic. It's just like doing calls, and we want to monitor that in a distributed system. And I'm not doing anything fancy, so I'm not using any Spring Boot services like load balancing, auto discovery, whatever. I will use the following definition of microservices, like as long as everything is very short, it's also micro in kind of some sense. So I'll not dive into any microservice topics or anything, we'll just focus on that monitoring and tracing side. So I will run everything in the cloud, so you can actually interact with that service and we will see your calls afterwards. That is where it's running, though I won't go into any of the tools or anything. Like, you have all the code there, it's fully automated. I just create my cloud instances automatically, I deploy everything. The code is in there, though I don't want to cover that. If you have questions, just come to me afterwards and we can talk about those tools as well. We have our own cloud service where this is running. Since I'm lazy and don't want to host Elasticsearch and Cubana myself, I will just use that. If you want to run it locally, you can totally do that. I've heard that you need to mention Docker in your talk at least once by now. So we have done that now. You could run it in Docker locally as well, but then you could interact with it, so I will try to run everything off the cloud. And I'll just focus on the open source tools, so you can just use whatever I show you right away afterwards without any licensing fees or anything. What we'll cover mainly is, so Elasticsearch is our oldest product, that is where we store the data. Then we have the beats. Those are like lightweight agents, shippers, forwarders, whatever you want to call them. They are written in Go, so you have native binaries, and they are just collecting information as efficiently as possible, and then forwarding it into Elasticsearch, where it is being stored. And then we have Cubana on top for the visualization part, which will fetch the data out of Elasticsearch. You could also use Logstash for some tasks, though for today's example, to keep it simple, we don't really need it, so I don't have Logstash in our example. But Logstash is also not going away. Like, if you need to query some APIs which we don't support in the beats, Logstash is a good solution. Or if you need to fetch data out of a relational database or something like that. So Logstash has still its kind of value and use case, just not for this demo today. So let's do something. I will need, let's make that a bit larger. I need an SSH session, and that is the right one. Is that large enough for everybody to see? Or I'll make it a bit larger. So I've logged into my instance. Let's start with Cubana. You will interact with these URLs afterwards as well. If you log in, you will just see kind of a limited view here. But generally, the domain I'm using is Xiera, which is a rod 13 of my last name. So if you rotate the letters of my last name by 13, that is what you get. And the good thing about rod 13 is, like, encryption and decryption is the same thing, because if you rotate by 13 letters again, you will come back to the original. So that was kind of very popular in the beginning of the internet. Like, if you wanted to post a spoiler and nobody should accidentally read it, you could just rod 13 encrypt it and nobody would accidentally read it. And yeah, if you take my name, something more or less readable comes out. And since this is a demo, I'll just use WTF as the domain. Which is, I think, kind of the right thing for a demo. And now we can jump into Cubana. So this is what Cubana looks like. I'm already logged in here. If you have never seen Cubana, we have kind of like the menu points on the left-hand side. We will mainly cover Discover. That is where you can basically see all the single entries or documents that you have. Visualize, where you can actually build some visualization to show or build a graph. And then you can combine multiple visualizations into one dashboard, and we'll then see the dashboards. And I've imported quite a few of pre-built visualizations and dashboards already. Since I'm lazy and you can be lazy too, you can just use what is out there. So these are the main features we're using. If you've seen other versions of Cubana, they might have like slightly different layout or slightly different colors, but they probably looks pretty familiar. I always describe it like this. Cubana 3 was black, Cubana 4 was white, 5 was colorful, and this is the upcoming 6 version that is kind of blue. And the blue because we have been told that the colorful was not good if you were colorblind. So this is what this looks like. And I'll collapse the menu because we don't really need that. So the first thing is I kind of want to start low level. I will just start with the system resources. So we have multiple beats to collect multiple pieces of information. The first piece of information we're interested in are metrics. So right now I want to go into system metrics, and the beat for that is the so-called metric beat. It collects both system metrics like what top could give you, but it can also monitor other applications, as we will see a bit later on. I will limit that down. You can see these are all the pre-built metric beat dashboards that I've just imported. So I didn't build anything myself, I've just imported that. And I'll start with the system overview here to see what is going on. So you can see we have 3 instances running. They have some CPU and memory usage. That instance is already like using 60% of its memory, the other slightly less. Yeah, CPU usage, that's all good and fine. And now I will just start something and see how the collection of information is going. So I will start the typical Java program that allocates memory until it runs in an out of memory exception. Let's see how that goes. So I have my so-called bad jar, and the bad jar will really just allocate memory until it has filled up its entire heap, and then it will crash and burn. So let's, and there is a space too much. If you leave out that space, it will just start allocating memory. So this will work here, and hopefully we will see if I enable auto-refreshing here. Let's say this page should auto-refresh every 5 seconds. You can see the memory consumption is already starting to jump here. So right now it's on 70%, and maybe after the next refresh we'll get, we get even more memory usage. And you can see something is wrong with my system. You could just say, I want to see what is going on that specific node. So you can see I have filtered down to that instance here. And you can see, okay, this is what this one instance is up to. And for example, here you can see, okay, this is how much memory is being used and how much is free. And that free is pretty stable still. But you can totally also build your own visualizations for that. So this is just what we have built, and you can see, okay, this is one system, and this is how this one system is behaving, like how much network traffic is it using, which are my top processes. Like you can see, Java is using up most of my memory. You could also switch that over to say, I want to see all my nodes in an aggregated fashion. And then it will show you these dashboards all combined. And here you could see, okay, something was up with my memory here. So it was kind of weirdly jumping around. And we might want to dive a bit deeper into that. So we can build our own custom visualization for that. So I'll just go to visualize and say I want to build a new visualization here. And these are all the charts you can pick in the upcoming version. Like most of them are, or all of them actually are available already. And one of the newer ones, which depending how familiar you're with Cubana, you might not have seen, is a new so-called visual builder. And the visual builder is basically kind of clicking together some more extended visualizations. So what we can say here is I'm basically interested in the memory, so I'll just call this field memory. And right now we see the count of all the documents we have in our system. So per average time slice, which is 10 seconds, we have around, I don't know, 400 documents or so on average. But I'm not interested in the overall count right now. I want to see the sum of one specific field now. So I can say system.memory, and then we have somewhere actual used bytes. And you can already see, okay, here was a spike. But it's not that readable. So the first thing I want to say is like, this is not a number, these are bytes, and it should be visualized as such. And you can see, normally I have a memory usage of 1.7 gigabytes. Here it jumped to 2, and now it was 1.6 again afterwards. But this is fully aggregated. So this doesn't really show you what is going on a per instance level. So what you can then do is you can say, I want to group this in some form. And I have another field called beat.name. And that name actually contains the full URL that you had. And here you can see like these are all my instances which have been running, and then you can clearly see like here was the spike. Like here the front-end instance spiked up to 900 megabytes of memory usage, and that instance only has a gigabyte. So that was kind of close to critical, and afterwards everything quieted down. And if you see that here, we ran into our out of memory exception here. So this was a feature for this example. So this is just the system level monitoring, and that's pretty easy. The next thing we want to do is we want to do or get some actual traffic and see how that is going. So you can grab out your phones or laptops or whatever, and if you just hit that xera.wtf, you will get that page. So this is the point where everybody should get out their phone and do something, because these are the requests we're actually monitoring from now on. So I need some requests. So that is xera.wtf. And you can just click on any link, and you can see you can get a at 200, you can get a 200 with the parameter. You can add your own parameter here. So whatever your name is, you can just edit here, and we can afterwards find it. That's the second link from the top. Or you can also trigger, I don't know, I'm throwing a null pointer exception. I'm throwing a runtime exception. Some pages not found, and we get a 404. So it does various things, and we'll just try to monitor all of these things now. Once we have all these requests. So the first thing we want to monitor is kind of the network level. So we have another beat for that called packet beat. And what packet beat does is it basically monitors the network traffic. It's a lot like Wireshark, but running Wireshark on a distributed system is kind of a pain because you need to run Wireshark on kind of all the different services and then aggregate it together to get a global view of what is going on. Whereas packet beat, it's using the same base library libpcap and is just extracting information from the headers. So it will know that request was an HTTP request. The whole thing took 100 milliseconds. You requested foobar, and the return code for foobar was 404. And it can tell you all of that and extract that information. So I'll just jump to that dashboard here. So the beats understand various protocols. And you have generally an overview. I'll start just with the overview just to see what we have. You can see here we have our requests. Thanks for all the requests. I don't have a database or a cache running right now, so these are empty. So we just have web transactions. Then you can see like these are the requests, the number overall, and how long they took. For example, you can see the green stuff is up to 10 milliseconds, how long the request took. You can see response percentiles. So previously everything was very flat because we had very few requests. But here the 95th or 99th percentile are spiking quite a lot already. And now even the 75th percentile is taking a bit longer. And once you see such a spike, you might want to dive into that to see if that is kind of still okay or if you should need to change something here. You can see also the OK and error rate. And actually that color scheme is not great. Let's make OK green and error red. You can just change everything on the fly. So you can see here, once you've started doing 500s and 404 requests, we got more errors. Here we get a breakdown of what are these errors actually. So you can see most of them are HTTP now. We have some DNS errors as well. And you can see a latency histogram too. So you see most of the requests were very fast, but somebody was very unlucky and probably hit, somebody had to wait 3.4 seconds for their request. And I didn't have to instrument my application in any form. This is just from the network layer. So it's just extracting that from the headers. So that's very simple and you can just use it directly. If we do not understand your protocol, or if your protocol is encrypted, we can only fall back to plain TCP/IP information, and then we get something like this, which is just kind of the connections over time. But that can also show you quite some interesting stuff already, like how many connections do I have right now, and is this still a sensible value? You can see which IP addresses are communicating with who, and at the end you have kind of a list like who is talking to who and how much traffic is that generating. But if we understand the protocol, like HTTP, we can actually see what is going on here. So you can see once you started doing your requests, we got up to 104 requests here and keep having some requests down here. Overall, in the last 15 minutes, we had 450 requests or so. Most of you hit the good endpoint, so we had 99 calls to good, and that yielded a 200. And let's switch that to green again, so it looks kind of nicer. So we have nearly 100 requests for good. Then we had some requests for the 404 page and so on. You can see which error codes did happen and also which URLs were mostly hit. So you can see good, foobar, base URL, etc. And you're a pretty serious crowd because nobody did anything weird. Like, depending on how creative you get, like sometimes I get bad words in there, and sometimes people write little scripts to just call whatever they're trying to hit like hundreds of times, so that would jump to the top of the list. What people have also tried is doing like a cross-site scripting injection. So they do a script tag and then put an alert in that, but we do escape that. So even if you call that in the URL, we would escape it, even if you would try to do an alert here. We don't actually call that alert then. But you can call whatever you want, and you would just see what is going on here. However, the URL was, or the calls were encrypted. I assume, or it's probably hard to see on your mobile phone, but all the calls were HTTPS. How did we see what was going on inside the traffic? Did we break the encryption? Yes. So I used the reverse proxy, Nginx, which is terminating TLS, and I was just looking into the traffic while the reverse proxy handed over the traffic to the Java application. So my Nginx is terminating TLS, and then handing over to my Java application. That is the only point where I can actually see what is going on. Otherwise, you wouldn't see anything from the protocol level. You would just see the flows, like who is communicating with who. But we cannot break your encryption, and that is kind of a feature as well. So that is what you get. So these are all the calls that we have done, but we can do more. So even if you had encryption enabled and we were not able to see the packets, we have a lot of that information somewhere else as well. So I assume most of you know since we have said we are using Nginx, we have the Nginx access log. And let's jump to one entry here. You can see from that entry, we have kind of a lot of information already. We don't even need to go to the network layer. We can just use the access log, and you can see we have the IP address, we have a date, we have the HTTP verb, we see which URL was hit, HTTP version, we see the 200, that is the response code, the 3506, that is the bytes being sent back. We see a user agent and operating system. So we have a lot of information there. So we could get a lot of information out of that as well. And kind of the good old way was to use the ELK stack and then have logstash and tell logstash, okay, this is the file, I want to collect this file, and then write a regular expression basically to parse that into the different fields. So you could then operate on the different fields. And you can totally do that, but at some point we figured out that probably it's not much fun and it's very repetitive. A lot of our users are using Nginx and then need to parse Nginx, and it's no fun to tell them, well, find that regular expression and then configure everything for you. So we have kind of added modules now which can do that for you. So to collect log files, we have another beat called filebeat. And what the filebeat does basically is it can collect files explicitly, or you can use a filebeat module. And for the filebeat modules, we have Nginx, for example, or Apache, or MySQL, or system level information. And when we tell the filebeat, like monitor Nginx, it will figure out on your operating system, which is Ubuntu 16.04, the access log of Nginx is var log Nginx access log, and it will know the default pattern, which looks like this. And it will do everything for you automatically. So you don't have to do anything, you just need to tell it like monitor Nginx and store the right information. And we will even enrich that with some more information, as you will see in a moment. And of course, we have built a dashboard for that. So for the filebeats, these are all the filebeat dashboards we have built, and I'll jump to the access and error logs directly. So you can see where our requests are coming from. Let's see. So that here is just from the IP address. We basically do a geo-IP lookup, and sometimes that information is very good, and sometimes it's rather poor. But today it looks okay, at least. I can jump in a bit more. It always depends a bit on the quality of the geo-IP information you have. And that is actually, it's slightly off. We're somewhere here, right? Or my geography in Kiev is not that great, but I think we're a bit more to the west, basically. But it's very good. At least it knows we're in Kiev. 12,000 results are from Kiev. So that is pretty good. It sees like when were the requests done and how many. So I assume somebody wrote a script now because we have nearly 10,000 scripts, 10,000 requests now. But we can handle that. That's fine. You cannot break anything. That's totally good. Is it a bash script, or are you running something more elaborate now? But let's see how long we can keep up and what is kind of dying first. That's a good experiment. It's all good. You can see, okay, these were the pages we have called, and you can see, okay, normally you would now see the breakdown of the user agents, but since you're not using a proper user agent in that script, it's kind of like distorted. So yeah, normally you would have like a decent amount of Chrome, Java, and mobile Safari. And now normally you could say, I don't know, what we have, like iOS, and then you would see the iOS version and everything. But this is very small right now. So let's just see the iOS breakdown. And I want to just see the requests coming from iOS now. So basically, I've clicked on that plus, and we have added that user agent filter now just on iOS, so I can actually see what people are using. And then you can see, obviously, everybody here has upgraded already. There is not a single iOS 10 user left. Oftentimes, but that was too small here now, you could also see, like, often I have a single Windows Phone user, and it's very easy to pinpoint then in the crowd who is the Windows Phone user. Okay, but we can throw that filter away, and once you see everything again, yeah, whatever script is taking over here and the user agents are kind of disappearing. And you can see we're also pushing a bit more traffic by now, but it's all good. Since it's a very simple service, it's probably hard to kill, and I assume the network is kind of like the limiting factor. And yeah, okay. You can probably do around 20,000 requests per 30 seconds. Not bad. And everything is still alive, so good for that. We can also monitor other stuff. So for example, the FileBit modules can see system operations. So we could see like everything that syslog is doing. So everything something is capturing, and you can see, okay, packet beat is kind of probably the first thing that's going to die here, because it needs to analyze all those 20,000 requests per 30 seconds. So you can see what that is logging out. And yeah, so packet, oh no, systemd, packet beat was not happy with here. And it stopped and then restarted packet beat. Well, that happens, but at least you can see it here and could search that. You can also see, like, when did I run the last sudo command? And I think I didn't run the sudo command now, but you can see in the last 24 hours, these were all the sudo commands I ran. And when I did that, so most of them were yesterday. Or what you could also see is you can see SSH logins. Did anybody try to log in by SSH into the instance? No? Okay. No worries. Normally, other people try to do that, so you get decent amount of requests, so you can see, let's make invalid red so you can see that a bit better, and errors, I don't know, let's make them light blue. And so you can see, like, these were all invalid requests, like these failed, and then we had some SSH errors, and this was the one accepted request I did just now. So most of the successful events in the last 24 hours, okay, that was me, that I just did that, yeah, I did those yesterday, so that's good. While I was sleeping, nobody logged into my boxes by SSH. And then you can see, like, which are the usernames people are using and failing to log in with. And then you can also see, like, where are the requests coming from. And normally, Russia doesn't disappoint. So normally you get a lot of stuff from Russia, but today China is also very strong. So they had 30 here, and you can see, okay, here Russia, but Russia is a bit split out. No, but looks like China is winning today. And then what you could do is, you could just filter down and say, I just want to see some information here. So I can draw any shape. Let's say I want to build that shape here. I think I got all my Russian points. So you can just click down on that map, and what that basically does is it sets a filter on these geo points and checks that everything is in those points, and you can see these are the most common usernames people from Russia are trying on my service, and it's not that creative. But depending on the region, like, you would probably get different usernames, and you could just limit it down, and then you can see from where somebody is trying what and which IP address and everything. Okay, getting back to our application. We got some 500s, and now it would be very nice to see what these 500s actually were. So I'm logging in a lot of information. Both Nginx is logging, system is logging, my Java application is logging. So the first thing I have is, I only have a Java application here. You could have other applications or services or whatever. This is just a random field I have set. And I say, only give me the information of what I have in Java. And then from my 220,000 requests in the last 24 hours, let's just make that down to the last 15 minutes where we have done our requests. And then you can see, even our poor little Java application had like 83,000 log events in the last 15 minutes. And you can see those. And then you could open those. And how would you normally log? So the kind of the classical log you would get is I'm just logging out to something called apps, and this is the front-end instance, and you would get something like this. And you can see here you have a good amount of information again. You have a timestamp, you have a log level, you have probably a log message and some other stuff. And now you could parse it again, but parsing is always a pain and you don't really want to do parsing. So what you would do instead, or what I'm doing instead, since I'm lazy and it's kind of a feature, is I log out to JSON directly. So that log message in JSON would just look like this. And you have everything structured already. So you don't need to do any parsing. You can just store it directly. And now we can directly interact with that. So now we can say here in all the JSON fields, I can just say like, let's see, what log levels do we have? Like 96% were infos, but I'm interested in the errors now. Just show me an error. And now we can see one of the error messages, and you can see, okay, servlet threw some exception, and you can see this was the actual exception. So my bad, something went wrong was my log message, and then you can see the entire stack trace. By the way, we are also enriching that automatically with the cloud information. So you can see this is the AWS instance where is this running. You can see the region, which instance size there is. Like we enrich and add a lot of information for that so you can easily see what is going on. So this is all nice, and now you might be interested in like how many unique exceptions do I even have in my system and how often do they occur? We have one other nice feature here, which is called stack hash. Basically, we throw out of the stack trace everything that changes between requests, and we only hash kind of the constant part for one stack trace. And now we could just visualize it. We don't have a pre-built visualizations for that, so we can just build that ourselves. I stick with a vertical bar chart, so that is a file I have collected, and my x-axis is the term, and the term I'm interested in is, there is the stack hash field. And you can see over the last 15 minutes, these 3 different stack traces occurred, like this one 24 times, this one 17 times, and this one 12 times. So probably you want to cover this one first. And then you could kind of break that further down and see like, is that bound to a specific thread, for example, or whatever user information you have. So whatever you logged with that thing, you could see like this thread was most accepted, then this, and whatever makes sense here, you could just figure it out. And then you would probably try to fix that stack trace first and then the others. So that was the logging part. The next thing you might be interested in is my service still up and running? So we have another beat for that. And that beat is called heartbeat, which is kind of like not that surprising. So it's just pinging stuff and sees if they're still available. So if I go to heartbeat, you can see these are all the services I'm pinging here. And okay, up is kind of this pinkish color. Let's make up green and down red. So that's kind of easier to see. You can also see like where do you spend your time? The lookup of the DNS entry, the HTTP connection, the TCP connection, or the TLS handshake. So this is actually broken down in where did the request spend their time. And you could see like this heat map afterwards, how much time am I spending where, and which is the kind of most common time. So most of the requests take about 50 milliseconds, some 100, and some less than 50. And somebody was unlucky and had to wait 200 milliseconds. And now we could just stop a service and see it go down. Should we stop the Java application or Nginx? Java? That is the front-end instance. I've just demonized it, so we have a service. So my pinger is running every 10 seconds. And the dashboard is refreshing every 5 seconds, so it will take, I don't know, 15, 20 seconds or whatever until it's down. And you can see, okay, here something is down. Here it says, okay, like 16% of your services are down. And it will actually tell you what the response code is. So if I had stopped the Nginx service, you would get a different error. Because right now, if I refresh that page, you will get a bad gateway because Nginx is there, but the proxied instance is gone. So you get a 502. If I had stopped Nginx, you would get a different error message. So you would see directly what is actually down and where your error is. And now we can start it up again. I think since this is a small instance, it will take about 15 to 20 seconds until that instance is up again, and then we need to ping it, and we will see at some point that it's there again. But it will reappear. The next thing, once the application is back up again, that could be interesting is since we're using Spring Boot, they have these actuator endpoints, which actually tell you stuff about how your application is doing. So we can ping health, and as soon as my Java application is back up, yes, it will tell you something. So for example, it will show you here that the status is up. Or you have also this metrics endpoint, which will tell you stuff, for example, about garbage collection and how many requests you had. And that is all relevant information, but it's very ephemeral. Like you kind of call that, you see what is going on, and afterwards it's gone. It would be very nice if we could collect that on a frequent basis and then store that as well. And that is also what metric beat can do. So the metric beat has an HTTP endpoint it can ping, and it's basically pinging that every 10 seconds and storing that information in Elasticsearch since it's JSON already. We can also do JMX. So we can also collect information from a JMX endpoint. And then you can just visualize that. For example, what would be interesting now is I just build a quick custom visualization again. Let's say I'm using my visual builder again. What I'm interested in here is now I would be interested in the heap, and I want to see the heap of my Java applications. And I'm exposing that by JMX. I'm using the JMX information. Let's quickly see how the heaps are developing over time. So we're using the Jolokia library, and if I could type Jolokia, it would show up. Metrics, memory, heap usage used, heap usage used. Heap usage used. That looks good. So you can see overall. I'm switching that over to bytes again. You can see this is overall what I'm using on memory, and now we can break that down to the specific instance again. And here you could, for example, see like. This is how my heaps are developing over time in general. And here I have stopped my front-end application, so there was no heap. And it was just gone. Like that is kind of expected. So if I filter down to that instance, you can see, okay, here the application was also down, and otherwise that is what it's doing heap-wise. And since we've just restarted it, well, the heap is a bit smaller than it used to be before. So that is also very easy to see and find. Okay, one more thing that might be interesting is, did you deploy something? Or when did something change? Let me quickly copy one of my commands because I'm always forgetting them. So I'm deploying my application now. Basically what I'm doing is I'm deploying the bad application because that one has like, I don't know, 13 kilobytes or something like that. So it should be super quick to deploy. And I am, of course, in the wrong directory. Oops. So I'm deploying that, and at the very end of my deployment process, I will write out an event to Elasticsearch, so I can actually see what has been going on. So in Elasticsearch, I can show you that in Cubana now. What I want to have, or what I'm storing is every time I'm changing something on my system, I'm actually storing that out to these events. And here you can see this is one event I have written out. So what I've done here is, here I've done a deployment. And I have configured an instance, and I called something. This was not the Java application, but this was a system application. The user who did that, the host, because otherwise you would run around your office and shout around like, who changed something in the system? Everything is screwed. Or I have more 500s now. Who did something? What happened? But here, I'm just like writing that out in explicit fashion so I can actually see who changed what. So both any configuration change and any deployment will be logged in here. So what can be interesting is we can be interested in system, application, and user, I guess. Or no, let's say host, application, user. Those are good fields. So we can then say in our visualization, I want to annotate that. And we have that field annotations here. And we get that from events, and we said user, host, and application, I think. And then you could say something like user deployed application to host. And I don't know, you want to tag, or we can add a bug or whatever. And then you can hover over that, and it would tell you Philipp deployed bad to the front-end instance. So it will actually, you know to who to go and to scream at who why something broke. So you can just log out all the events and then can annotate them on your charts. So that should be very helpful to show you when stuff is breaking and why. So, final thing is traces. We have covered all the rest basically. And for example, when you do a very slow 200 with a background task, and that takes some time, and you say, this is so slow, and you want to know why it's slow. Because normally this is a very hard question when somebody comes to you and says, like, your operation is slow. So there is Zipkin or distributed tracing that you can use. I'm just using the Sleuth plugin, basically, or component for my Spring Boot application. Basically what this does is the first time a request hits your application, it gets a unique ID, and then as that call is kind of propagating through your system, it will always keep that ID, and you can see what is going on. And then you can actually visualize that. And that is on my monitoring instance. So this is Zipkin. You can see this is being developed by backend developers and not frontend developers. And you can then just say, give me the traces, and then you can see somebody called something that took 2.5 seconds. That's not really what I want our users to have. Like, nobody wants to wait for 2.5 seconds. So you can click on that, and then you can see, okay, you called something, like that already took some time, you called that slow thing, and then you called slow call. And that slow call was super fast, like that was 4 milliseconds. But that one here took 1.7 milliseconds, like what was going on here? And then you could just, for example, click on that, and it would give you some more information. And why this was so slow is, I kind of cheeked it. I do a random sleep, or a thread sleep random here, but I've logged out the information, so you can see this thread was, or this call was basically sleeping for nearly a second. So you can add more meta information here, and you can actually see what was being called, which instance, which method, which URL, and then you could dive in and see, like, why was this so slow? Where am I spending my time? And Zipkin has multiple backends. One of them is Elasticsearch. So in our demo, everything is being stored in Elasticsearch as well. So that's working out nice and easy. And for example, there is one more thing you can do is you have a Zipkin plugin for Chrome, which is probably very hard to see. But if you reload that page and it takes a lot of time, it will give you kind of the direct link to that. So if you're kind of developing and see something is slow and you want to see, like, what is even happening behind the scenes here, you can then just click on that directly, and it will take you directly to that call, and you can see where did it spend its time and why was this so slow. So, since we're nearly out of time, finishing off. What is coming for the future? So we grow frequently by buying new companies. So we buy every 6 to 12 months, we add a new company to our stack. So like a few months ago, we acquired a company called Upbeat. Unfortunately, this has nothing to do with the other beats, but this is an APM company, so application performance monitoring. And what it will do is it will integrate kind of this call list, and it can even link down to, like, this call actually was caused or was done by this code, and then it can even link down to that line of code was written by that little person there, like the icon. So you can actually see who wrote the shit code, why something is slow. And we're currently integrating that to our stack, so we have Node and Python right now, and frontend, like React and Angular, are coming like within 1 or 2 months. We don't have Java yet, for example, but we are working on that. By the way, we're hiring somebody to do that, so yeah. We're always hiring people. Like, I think that the target to hire in the next few months is like 200 people or so. It's pretty insane. Yeah, but we'll get more into this APM solution space as well. So, to wrap up, I always compare our stack a bit to Lego. Like, you have all these building blocks. There is some assembly required. You need to put together some stuff. But we try to get more into that solution space as well. So you have all the building blocks, what you can put together, and we're trying, like the FileBit modules, trying to give you a solution how to do stuff. We've seen quite a few things. What I skipped today, for time reasons, is AuditBeat. So we can, for security auditing and file changes, where you could see, for example, has something changed in my deployment units? You could monitor those as well, just for the integrity of files, for example, or see who changed what at what time. We can monitor those as well. We've seen uptime pinging metrics. We have seen request tracing with Zipkin right now. If you want to do anything and take home, like if you want to play around with the dashboards, you don't need to log in. The Cubana reverse proxy is doing that for you automatically. So you will be logged in with a user who can only see kind of the dashboards. that is the top link. And if you want to see all the configurations and the code, that is the bottom link. So if you just want to see how to build up all of that stuff and dive into the code, this is where you can get it. And with that, I think we're exactly out of time. If we're out of time, we can just do the questions like, come to me afterwards. I have a bunch of stickers down here. So if you're quick, you can just get as many stickers as you want. And I'm always taking a picture with you so I can prove to my colleagues that I've been working. Because nobody normally knows where I am. Smile, everybody. Thank you very much.